In this video, we're going to look at writing the full and abbreviated electron configuration for elements, and we're actually going to add in how to write the configuration for ions, which is almost exactly the same as writing it for an element. We have to take into account the fact that ions have either more or less electrons than a normal atom would. So remember that this is what we call the Aufbau sequence. This is the order in which the energy levels and sublevels fill up in any atom, all the way from helium and hydrogen at the beginning, all the way up to element number 118 at the end. So we will use this sequence when we write the electron configuration. So there are two ways to do this. We're going to write out the full notation using numbers, letters, and superscripts. This takes the place of the boxes and arrows that we used for the orbital diagrams. And it gives us the same basic information without quite as much visual detail. We're not going to see the individual orbitals, the spin of the electrons, and which electrons might be filling either partially full or filled orbitals. That's information that's useful in some cases, but for right now, we're going to use what's more of a shorthand way called the electron configuration notation. So let's take a look at oxygen. Remember, we have the Aufbau sequence. Oxygen is element number 8. So we need to fill it with 8 electrons. So the first energy level, level 1, has an s orbital. That s orbital can hold 2 electrons. So there's the energy level, the sublevel, letter S, the little number 2, which is called a superscript. Okay, that goes up above like an exponent, 2. The next level is level 2, because level 1 only has an s orbital. Level 2 has an s orbital that can hold 2 electrons. The second level also has a p orbital, which can hold up to 6 electrons. In this case, we already have 2 on the first level and 2 on the second level, so we only need 4 more in order to get up to the 8 electrons that we need for oxygen. So that's one key thing to watch, is that the numbers along the top, the superscripts, should add up to the number of your element. And we'll make a slight adjustment to that when we get to ions, but the numbers on top add up to the number of electrons in your particular atom or ion. So again, keep in mind that even though the p sublevel can have 6 electrons, we only needed 4, which means this is an incomplete sublevel. It'll have either empty or half-empty orbitals, which we would see in the orbital diagram. It would look like this, where we would have 2 electrons in the first orbital here, then 1 here and 1 here. That's the 4 electrons. Okay, so here's what that looks like just typed out. And again, the first number, the big numbers, the 1, the 2, those are called the principal energy levels. That's like the floors in the building. And then the letter that follows, the S, and in this case there's 2 S's and a P, and then we would have D's and F's if we went higher up in the periodic table. That indicates the sublevel, which tells you how many orbitals and electrons you can have. So S can hold 2 electrons because it has 1 orbital. P can hold 6. D has 5 orbitals, so we can hold 10. And then F, if and when we get there, has 7 orbitals, so we can hold 14 electrons. That's the maximum. Now, they don't have to have that many, but that's how much it has when it gets full, and that means you'd have to move on to the next one to put any more electrons in. So let's take a look at sodium. All right, sodium is element number 11. So we have 1s2, 2s2, 2p6. Okay, so there's 2, 4, and 6 is 10. So we're up to 10 electrons. We need 1 more, and this p sublevel here is full with 6 electrons, so we have to add a new level, which is level 3. And every single level starts with S. So anytime you move on to a new number, this is the one thing that's always true. When you move up to a new energy level, the first orbital is always S. And then after that, sometimes it gets a little bit different because some go from S to P, some go from S to D, and so on. But the first sublevel on every energy level, you see here, is S. And in this case, since I already had 10 electrons and I only need 11, I just need that 1 extra electron on the third level. So 1s2, 2s2, 2p6, 3s1 is the configuration for sodium. So let's take a look at a little bit bigger element, and I wanted to show you this one because it does involve the D sublevel, and the D sublevel is one of those that overlaps where the numbers don't go quite in order. So bromine is element number 36. So we're going to start over here with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. This is where it goes down to 3d10. And then after 3d, and this goes back to the Aufbau sequence. So if when in doubt, just go to that list and put the numbers and sublevels in order, even when the numbers themselves seem to get mixed up. Sorry, that should be 4p, not 4s. We already did 4s. And 4p, 5. Oh, I messed that up. Bromine is actually number 35. I knew I had the configuration right. I couldn't figure out why the numbers didn't add up. Bromine's number 35. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, that's where it gets out of order, 3d up to 10, and then 4p, 5. So that adds up to 35. So as you can see, that was number 36. Sorry, number 35. Keep messing that up. Number 35, which is barely even a third, not even a third of the way through the periodic table. It's barely a quarter of the way. So very quickly, writing out the full electron configuration becomes tedious, challenging, takes a long time. So let's just look even at potassium, which is number 19. And I double-checked myself this time. It is really number 19. 1s2, 2s2, 2p6, 3s2, 3p6, that's 18, and then 4s1. All right, so again, it's not, 100 different numbers, but even writing that out takes a minute, and you got to get through all those numbers and letters. So if we look, the first 18 electrons are equal to the noble gas called argon. Argon is element number 18. Every single element is builds off of the elements that came before it, right? So argon is number 18. The only difference between argon and potassium is one more electron, that 4s1. And the only difference between, for example, potassium and calcium is calcium has one more electron, so it'd be 4s2. So every element contains the configuration for the elements that came before it, and then just gets added to each time we move up one element. So here's potassium, and here's argon. And so again, you see that the first 18 electrons of potassium are the same as the full configuration for argon. So what we're going to do is we're going to use what's called the noble gas abbreviation or noble gas notation. I'm going to use the symbol for argon to substitute for those first 18 electrons. Because again, the first 18 in argon, or all 18 for argon, are identical to the first 18 for potassium. So we write the symbol for argon to symbolize those first 18 electrons. Argon's element number 18. The only thing we have to add to that is the difference. So remember, this is the first 18 electrons. Potassium's number 19. So the only difference between argon and potassium is the 4s1. So by writing the argon in brackets, it replaces everything that was in the potassium configuration up to 3p6, which is where argon leaves off. And the only difference is what comes after number 18 to get to 19, which in this case, again, is only 1. So here's the trick with writing the noble gas configuration, and this will make the noble gas configuration, again, once you get used to it, it should be a pretty quick way to write out the configuration. So let's take a look here. Here is potassium, right? That's the one we were doing. The way to figure out how to do the noble gas notation is to look at the noble gas that is in the row above your element. Remember, the noble gases are all the elements in the last column over here. So that's all these elements. So when you're doing the noble gas notation, you're going to start with one of these elements in brackets. Okay? And then, so that's the first part, is which noble gas you're going to use. You always look at the row that your element is in and go one row up and all the way over to the last element in that row. So in this case, argon is the element in the noble gas column above potassium. So that tells me that argon is going to be the element that I would use to abbreviate the beginning of the potassium notation. The next, and this is the most frequently mistaken part of this, is what do I write after the brackets? Because we're not starting over at level 1. We've already done level 1, level 2, and level 3 when we put the argon in brackets. That takes care of the first 3 levels of this configuration. So here's the trick. Potassium is in row number 1, 2, 3, 4. Okay, 4th row of the periodic table. So the number that comes after the brackets is 4. And remember a little while back I said every energy level starts with S. So the number and letter that comes after the brackets will always be the row of your element followed by S. Okay? So if we're looking at, I don't know, pick any element. Tin. Tin is in row 5. The element, the noble gas above it, is krypton. So for tin, I would put krypton in brackets, and then I would start after the brackets with 5S, okay, because it's in the 5th row, and every level starts with S. That doesn't mean I'm going to stop there, but just if you can get this part right, then we're well on our way to getting the whole thing right. So, sorry, go back to potassium, right? This is the one for potassium, and we said this one is we're going to do tin, just to do a couple examples, and then we'll look at some other ones. So, remember argon is element number 18. So the argon in brackets is the first 18 electrons. Potassium is number 19, so I only need one more electron to get to 19. So I'm done as soon as I put that first electron there. Tin is a little different. Tin is number 50. Okay, tin is number 50. And krypton is number 36. So krypton gets us up to 36, and we have to get from 36 to 50. So we've got 5s, 2, and then after 5s, again looking at the Aufbau sequence, would be 4d. So I'm at 36, this 2 gets me to 38, another 10 gets me to 48, I'm almost there. The next level is 5p, and I only need 2 more electrons to get to 50, so it's 5p2. So krypton, 5s2, 4d10, 5p2. That's the noble gas abbreviated configuration for tin. All right, let's take a look at some other examples just to get you some practice. Now, it will take a while, probably. You might get this right away, but it might take a little while to get the hang of this. And at first, it's going to seem like it's way more work than it's worth. But I promise, when you're writing long configurations And especially in a little bit, when we talk about valence electrons, these noble gas notations will save you a tremendous amount of time. Okay, what is the noble gas notation for sodium? All right, so let's find sodium. Okay, sodium is here. If we go up and all the way over, the noble gas is neon. So we're going to put neon in brackets. Okay, neon's number 10. Sodium's number 11. Okay, so I only need one more electron. Where do I start? After the brackets, what row am I in? I'm in row 1, 2, 3. The 3 comes after the brackets, and it's always S, because every level starts with S. I was at 10 electrons. I need to get to 11. I only need one more. So that's it. Ne for neon, 3s1 is the noble gas abbreviated version of sodium. Take a look at a couple more, and then we will very quickly go over how to do the noble gas notation of ions, or the electron configuration for ions, which is doing exactly what we've been doing. So there's nothing new as far as the numbers and letters that we're using or the order that anything goes in. The only difference is the number of electrons that we're going to count. So we'll get to that in just a minute. So let's take a look at nitrogen. Nitrogen is here. So if we go up and over, we get to helium. Now, granted, this one is not going to save you a massive amount of time, but if we put helium in brackets, that's 2 electrons. Okay, only 2. And then after that, remember, nitrogen is in row 2, so it's 2s, 2, 2p, 3, because I have to get to 7, and I've got 2 with the helium, plus 2 more in 2s, and then I need 3 more, so 2 plus 2 plus 3 is 7. There's our noble gas notation for nitrogen. Again, you might not, since helium, you're only replacing the 1s2. Again, doesn't save you a lot of time, but just for practice, let's look at beryllium. Okay, same kind of deal here. Beryllium's over here. Go up one and all the way over, we're at helium again. So this is another helium noble gas. Beryllium is number 4, so all I need is 2s2. Remember, you start in row 2, so after the brackets you start with 2s. So beryllium, up one row all the way over is helium. That gets me my first 2 electrons, and then I need 2 more. So there's the 2s2, and it starts with 2s because I'm in the second row. Aluminum. Aluminum is here. We're in the 3rd row. So if we go up one and over, we're at neon. Neon is number 10. Okay, put neon in brackets. That gets me the first 10 electrons. You don't have to always write these numbers. I'm just writing them to show you while we're practicing. And then aluminum is in row 1, 2, 3. So we go to 3s, always s after the brackets, always the number of the row you're in. 3s2 gets me to 12, 10 for neon plus 2 here. And then I go 3p1. There's 13 electrons. That's the noble gas for aluminum. All right, copper. Copper is down here in this middle part. This is going to have a configuration that uses the d orbital. And if I go up one row and all the way over, I get to argon. Okay, so the noble gas notation is going to start with argon, which is 18. Copper is number 29. So I need to start with, let's see, what row are we in? We're in row 1, 2, 3, 4. 4s, 2. That gets me to 20. I need 29. So after 4s, in the Aufbau sequence comes 5d. 5d, nope, 3d. Got that wrong. Sorry, 3d. 3d9. Okay, so 18 plus 2 is 20, and then the 9 here in the 3d, that is the noble gas notation for copper. Okay, so let's take a look at a couple of examples of ions. Remember that ions are atoms. They're still atoms, but they're atoms that have either gained or lost some of their electrons, which is why they have either a positive or a negative charge. Because once you start changing the number of electrons, you're throwing the positive-negative proton-electron balance out of whack. So a magnesium ion, okay, magnesium is number 12. It's over here. We're not going to do the noble gas on this one, just because I want you to see the whole thing. Magnesium's here, number 12. So magnesium normally has 12 electrons, because it's number 12. But the fact that it's plus 2 means that it's missing 2 of those electrons. Okay, because now it has 12 protons, but now it only has 10 electrons. That's how it gets to a plus 2 charge. So when I write out the configuration, 1s2, 2s2, 2p6, I only need to include 10 electrons because magnesium plus 2 has lost 2 of its electrons. Okay, chlorine is over here. It's number 17, which means normally it has 17 electrons. But the fact that it is a negative, and when there's no number up there, it just means -1, that means it's gained an extra electron. So now it has 18 instead of 17. That's why it has a negative charge. So I'm going to write it as 1s2, 2s2, 2p6, 3s2, 3p. Now normally, so I'm up to 12. Normally, chlorine would be 3p5 and have 17. But because it's added that electron and it's got a negative charge, it's got 3p6, 18 electrons. So when you're writing the configurations for these ions, you can do one of two things. You can write it out exactly the way you normally would, and then either cross off or kind of erase electrons if it's positive, or add on a couple more. Or you can just figure out the number of electrons you should have and change the number and then write it out that way. It really doesn't matter. But just remember that if it's positive, it's lost electrons, so it's got fewer than normal by whatever the number is. So 2 plus means 2 less electrons. And if it's negative, in this case -1, it's got 1 extra electron, so you have to add that to the configuration. All right, so let's take a look. Just, I wanted to show you one of the bigger elements to show you what the noble gas notation will do for you here. So uranium, okay, uranium is way down here, okay, it's element number 92, okay. Now, a couple things you have to keep in mind with uranium. When we're doing the noble gas configuration, the periodic table is a little bit strange because this whole section down here fits into this little spot here. So uranium is actually in the row that starts with francium, which means it's in row 1, 2, 3, 4, 5, 6, 7. It's in the bottom row of the periodic table. Even though this little chunk of elements is broken off down here, that's because this whole section squeezes in between barium and lutetium and radium and lawrencium. Okay, and they just do it like this because the periodic table would be really, really wide if they didn't. So, if we were going to write out the entire configuration for uranium, 92 electrons, we would write out 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f5, 14, 5D10. I'm going to run out of room. 6P6, 7, S2, 5, F4. Okay, that's the whole thing. And it's completely illegible because I crammed it all in there, but I promise you that's it. Now, we're going to do the noble gas configuration. So remember that I said that uranium is really in this row right here. Okay? So it's in row 7. So if I go up and all the way over, I find radon. Okay, so my noble gas in brackets is radon. Radon is number 86. So I'm picking up from 86 and I got to get to 92. I only need to do 6 more electrons. Okay, and it starts with, what row am I in? I'm in row number 7, S2. After 7S in the Aufbau sequence is 5F4. Okay, so I had 86 when I got to radon, and then I added 2 on the 7S here, 4 on the 5F, and I'm done. So this, right, is much easier than this whole thing up here. Alright, so even though I just kind of wrote over it and made it look harder to read, alright, radon 7S2 5F4. Much easier than writing out that whole other thing. Okay, so those are your electron configurations, full, and abbreviated noble gas versions. So now take a look at the worksheet that's attached. There's gonna be another short video just in case you need help with doing the superscripts in Google Docs. Just a quick thing to show you how to do the shortcut to do that so you can format it correctly. And then you're going to do the electron configurations and the noble gas notation for all of the elements, and there's some ions mixed in there too on the last page. So take a look at those as well. And then you're going to type all your answers in there and submit it. And that's going to be your work for today.